Electrolysis and the products which are formed. Now, when the direct current is passed through the molten electrolyte or its aqueous solution, the chemical reaction occur at the cathode and anode. The process of chemical decomposition of an electrolyte by passing direct current through its molten state or the diffuse state is called electrolysis. Now, in electrolytic cell, it is a device by which the electrolysis is carried out. Electrolyte in molten state or in the dissolved state is taken in the glass vessel. The two metal strips are suspended in the electrolyte. These strips are connected to the battery. One metal strip acts as cathode while the other metal strip acts as anode. On passing current, reduction occurs at cathode and oxidation at anode. The product of electrolysis depends upon the various other oxidizing and reducing species present in the electrolytic solution. The product of electrolysis also depend on the state of material being electrolyzed. The products obtained by the electrolysis of molten NaCl, concentrated aqueous solution of NaCl, and diluted aqueous solution of NaCl are different. There are some electrode reactions which are feasible, but their rate of reaction is so slow that at low voltage these reactions do not seem to take place. An extra potential that is known as over voltage is to be applied to make this type of the electrode reaction to occur. When electric current is passed through an electrolyte, the cation move toward the cathode and get reduced there, and anion move toward anode and get oxidized there. Which ion is reduced at cathode and which ion is oxidized at anode depends upon their reduction potentials. Remember this thing, the species with higher reduction potential is reduced first. If a solution contains several cations, then these are reduced in the order of their E0 values. Higher the standard reduction potential value, they will reduce first. At anode, the species with lower reduction potential values are oxidized first. If solution contain all the halide ions, the order of their oxidation at anode will be I negative, Br negative, Cl negative, F negative. This means that the species with low reduction potential is oxidized first. If the solution is aqueous, then the hydrogen ion obtained from H2O may be reduced at the cathode and the OH ion may be oxidized at anode. It occurs only when the reduction potential of the H ion is greater than the other cation present. And OH ions are oxidized at anode if the reduction potential of the OH ion is less than the other species present to be oxidized at anode. The Faraday's first and second law of electrolysis. The Faraday's first law. During the electrolysis, the mass of the ion discharged at the electrode is proportional to the quantity of electricity passed. That is, W is directly proportional to Q, or W is equal to IT, or W is equal to ZIT, or W is also known as the mass, which is known as M is equal to ZIT. Z is the electrochemical equivalent. Q is the total charge passed through the electrolytic solution. I is the current of strength in ampere. T is the time in second. Electrochemical equivalent of the ion is equal to the mass of the ion discharged by 1 ampere of current in 1 second, that is by 1 coulomb of electricity. This is known as the Faraday first law of electrolysis. Now Faraday's second law of electrolysis. When the same quantity of electricity is passed through the different electrolytes connected in the series, the masses of the different substances produced at the electrode are proportional to their chemical equivalents. That is, the mass of the substance A upon equivalent weight of A is equal to mass of substance B upon equivalent weight of B is equal to mass of substance C upon equivalent weight of C. That is, for example, the mass of the copper deposited upon mass of silver deposited is equal to the equivalent weight of copper upon equivalent weight of silver. By this method, we are able to calculate the mass of the substances which are liberated at the different electrodes when they are connected in series and same amount of the electric current passed through them. Now the sum common batteries of the cell. The energy produced in the redox reaction is converted into electrical energy. Thus, a battery is basically an electrochemical cell. In a battery, two or more galvanic cells they are connected in the series. A battery should fulfill the following requirement. It should be compact, lightweight, small in size, and provide power for the longer period. It should be rechargeable. During use of the voltage of the battery should not change. The commercial cells are of the two types, primary cell and secondary cell. The primary cells, the redox reaction occurs only once. It then becomes dead and cannot be recharged again. The examples of the primary cells are dry cell and the mercury button cell. Dry cell, it is a compact form of the Electrolytic cell. It contains zinc. It contains zinc container having a paste of ammonium chloride and zinc chloride. The container zinc acts as anode. The container is lined with the porous paper which separates the zinc from the paste and allow the ion to pass through it. Graphite rod is placed in the center and acts as the cathode. It is surrounded by MnO2 and carbon. The electrode reactions are complex. These reactions are shown in the slide. Zinc change into Zn plus 2 plus 2 electron. MnO2 plus ammonium ion plus electron changes into MnOH plus ammonia. Now in this case, MnO2 is reduced from plus 4 oxidation state to plus 3 oxidation state. Ammonia is not given out as a gas, but it combined with Zn plus 2 ion and forming the complex Zn NH3 whole 4 2 positive. The EMF of the dry cell is 1.25 to 1.5 volts. During the use, zinc container is consumed and holes starts appearing in it. These holes are responsible for the leakage of the battery, and extra cover for the zinc container is provided in leakage proof dry cells. Now the second is mercury button cell. Now in mercury button cell, they are used in hearing aid machine, wrist watches and movie cameras. In this cell, zinc mercury amalgam is anode and the paste of mercury oxide and carbon is cathode. The paste of QH and ZNO is electrolyte. It gives out the constant voltage 1.35 volt. The reactions are zinc react with 2 OH ion, form ZNO plus S2 plus 2 electron. This reaction takes place at anode. At cathode, HgO mercury oxide react with water, accepting 2 electron, change into Hg plus 2 OH ion. Now the overall reaction is produced Zn plus HgO change into ZnO plus Hg. The cell potential is approximately 1.3 volt and remain constant during its life, as we are using it continuously, because the concentration cannot change during this reactions. The cell potential 1.35 volt remain constant during whole life. The overall reaction does not involve any ion in the solution whose concentration change during the cell reaction. Now the second is secondary batteries. Secondary batteries is the lead storage battery. Those cells which can be recharged again and again are known as the secondary cells. A good secondary cells undergo a large number of the charging and discharging cycles. In the lead storage battery, the lead spongy lead react with the sulfate ion to form lead sulfate and 2 electrons are eliminated. At cathode, PbO2 react with sulfate ion and 4H ion plus 2 electron change into PbSO4 plus S2. Now the secondary cells can be recharged again and again. It is clear from the above reactions that the sulfuric acid HNSO4 is used up during the discharging of the battery. As a result, the density of the H2SO4 falls. The battery may be recharged by passing the current in it from outside. The reactions are just reverse. Sulfuric acid is formed and battery can be used again. It is important to know that the recharging of the lead storage battery is possible because lead sulfate formed is solid and stick to the electrodes. Thus, on charging the battery, lead sulfate is removed into lead and PbO2. The EMF of one cell is 2 volt. If the battery contains 6 such cells connect in the series, the EMF is 12 volt. The another is nickel cadmium battery. In nickel cadmium battery, the cathode is metal grade containing NiO2 immersed in KOH anode is cadmium and electrolyte KOH is used. When the cell is used, the following reaction takes place. At cathode, NiO2 plus 2s2 plus 2 electron changes into NiOH voltage plus 2OH ion. At cathode, Cd plus 2OH ion change into CdOH voltage plus 2 electron. During use, only water is consumed as electrolyte. Its voltage remain almost constant. The product formed stick to the electrode. The cell is rechargeable. During recharging, the reactions are exactly reversed. No gaseous product is formed during the cell. Therefore, the battery is sealed and made compact. It is used in calculators, electronic watches. The EMF of the cell is about 1.4 volt. This is the fuel cell. The fuel cell is the device in which the chemical energy is produced by the combination of the fossil fuel such as coal, gas, oil. The heat produced is used for converting the water into high pressure steam. It is then used to run the turbines to produce electricity. The efficiency of the thermal plant is only 40%. But the galvanic cell directly converts the chemical energy into electrical energy and is highly efficient. It is now possible to make such a cell in which the reactants are fed continuously to the electrode and the products are formed, removed from the electrolyte compartment. The galvanic cell which convert the energy of the combustion of the fuel such as H2, methane, methanol, etc. directly to electrical energy are called the fuel cell. The first successful fuel cell is hydrogen-oxygen fuel cell. This hydrogen-oxygen fuel cell contains two porous carbon electrodes. These electrodes are impregnated with suitable catalysts such as platinum, silver, cobalt oxide. The concentrated solution of KOH, NOH is used as an electrolyte. The solution is placed between the two carbon electrodes. One carbon electrode acts as cathode, the other carbon electrode acts as anode. The hydrogen is bubbled through the anode and oxygen is bubbled through the cathode. The following reaction takes place. O2 plus 2s2 plus 4 electron change into 4OH ion. At anode, H2 plus 2OH ion change into 2s2 plus 2 electron. The complete reaction is 2H2 plus O2 change into 2s2O. What are the advantages of the fuel cell? The advantage of the fuel cell do not cause pollution. The electrical energy may be obtained continuously by the continuous supply of the fuel. Or third one, it is conventional battery. Less weight of the fuel is required in the fuel cell to produce a given quantity of electricity. The disadvantages of the fuel cell: the catalyst used, platinum, cadmium, silver, are costly. There is a problem in handling the gaseous fuel at high pressure, and the electrolyte used, NOH, KOH, are corrosive in nature. Corrosion. The corrosion is the process in which the metal combines